In this webinar, we went through the new features in the latest release of the nRF Connect SDK, including some really cool demos. First, we had Bluetooth shorter connection intervals, a new feature that was introduced in the Bluetooth 6.2 core specification. Also, we had a demo of our new Matter Quick Start application, a new application that allows you to evaluate Nordic's Matter solution without having to install the SDK or set up the development environment. And lastly, we demoed the S145 SoftDevice, a new SoftDevice variant in the nRF Connect SDK Bare Metal option. That is a multi-role, peripheral, and central operation SoftDevice. So let's get to it. Hello, everyone, and welcome to today's webinar. In this webinar, we're going to talk about the exciting features in the nRF Connect SDK version 3.2.0 that was released just before Christmas last year, 2025. I'm your host for today's webinar. My name is Tiago Montt, and I'm a developer marketing manager here at Nordic Semiconductor. Okay, so the agenda for today's webinar will start with some generic updates, followed by Bluetooth, including a demo. Then we'll go through Wi-Fi, Matter, also with a demo, Cellular IoT, and we'll wrap up with the nRF Connect SDK Bare Metal option, also with a demo. Okay, so let's get started with generic updates. And so we have two new devices that we've launched in the last couple of months, and they are now experimental as part of the nRF Connect SDK. The first device is the nRF54LM20 wireless SoC. So as it stands, you can use this device for Bluetooth LE, including channel sounding, as well as Bluetooth mesh, 2.4 GHz proprietary, thread, and Matter. Also, all standard peripherals are available, including the new USB high-speed interface, which is unique to this device. The other one is the nRF54LV10A Bluetooth LE SoC. So here we have support for Bluetooth LE, also with channel sounding and 2.4 GHz proprietary. And this supports also has usable all the standard peripherals. And we'll dive a little bit more into each of these devices in the next few slides to give you a better overview. That means that also the associated DK, so the nRF54LM20 DK and the nRF54LV10 DK are also supported, including in the Quick Start application. So if you get your hands on these kits, you can get started with Quick Start that has a step-by-step guided process to get you an easier and streamlined out-of-the-box experience where you can directly flash firmware from the application, as well as guide you through the installation of the SDK and the development environment. So these new devices, let's start with the nRF54LM20. So this is a high memory SoC. It's really geared towards applications that are a bit more demanding. They have more advanced application logic and sort of more higher level protocols like Matter over Thread and over Wi-Fi. So it expands the memory size compared to the existing nRF54L15. So now you get 2 megabytes of NVM and 512 kilobytes of RAM. And with all these resources, it brings you a lot of benefits. One of them is that it unlocks design flexibility. So you have a lot more punch and a lot more resources that you can use to develop your application, enabling more sophisticated, more complex devices. And of course, it brings some unique features to the nRF54L series, like the high-speed USB. It also has a higher count of GPIOs, up to 66 GPIOs, and some additional interfaces that are available. The LV10 is a little bit different type of device. So it builds, of course, on the wider benefits of the nRF54L series, but it is geared towards a specific segment. So in this case, it's for connected healthcare applications, specifically for continuous glucose monitors and other types of wearable biosensors. So, like I mentioned, you get all the benefits, all the wider benefits of the nRF54L series, like the efficient processing, the security, and of course the connectivity or the low power connectivity. But then on top of that, it also brings a feature set that's a bit more fit for purpose for these types of applications. So for CGMs, for wearable biosensors, and connected healthcare applications. So one of them is that it supports 1.5 voltage power supply, and this enables the device being directly connected or supplied by a silver oxide battery, which is a very common battery type that is used on CGMs, for example. It also brings the smallest package in the nRF54L series to date, 1.9 by 2.3 millimeters. And in addition, it has an integrated hibernation mode, where you can put the device in a sub 50 nanoamp current consumption mode for shipping and storage. So often these end products like CGMs and similar, they can stay in the supply chain for a long time, like from production to storage to get to the end customer. And you want to make sure that the battery is in a healthy condition when it gets to the customer. So that's what this hibernation mode is for, to reduce the leakage on the battery and make sure that the condition is top-notch when it gets to the end customer. And then trying to sort of frame these devices in the wider nRF54L series. So as mentioned, they all build on the common architecture. This gives you scalability and portability. So if you're not quite sure which device is right for you, you can start from a larger device and then go down to a smaller device, or the other way around. So trying to map these out on a plot. So memory size on the y-axis. So you have the LO5, which has half a megabyte of NVM and 96 kilobytes of RAM, and then all the way to the LM20, which has 2 megabytes of NVM and 512 kilobytes of RAM, as we discussed. And then on the x-axis, you have sort of representation of available peripherals. So the LM20 is, let's say, the more feature-rich device, which has high-speed USB and some additional interfaces. And then the LV10 has a standard set of peripherals with sort of less instances of each peripheral, as it's sort of geared towards applications that have just a few sensors and don't really require a wider amount of peripherals to be developed with. And as you can expect, we will, of course, continue to expand on the nRF54L series. So yeah, stay tuned for updates, as there will be more devices coming into the market throughout 2026 and into future years as well. Okay, so those were the updates on new hardware support. One more thing within the general updates. When we launched the nRF Connect SDK Bare Metal option in August last year, that brought single bank or single slot DFU to that software development solution. And we said at the time that we were going to bring this to Zephyr-based application development. And we're doing that now with the 3.2 release. So now we're introducing a single slot DFU over Bluetooth LE, and this is experimental. So this comes as a sample, which shows you how you can integrate this functionality with your application. So this sample demonstrates how you can sort of maximize the space for your application. The way this works is that, or the sample specifically, the main application is actually quite simple, and it does not have any update capabilities. And this is different from the existing dual slot DFU approach, where you essentially have always a copy of your application. So you always need to have space for 2 copies of the application on the onboard flash or using an external flash, which means that also need to have the update capability in the application itself. So what this single slot DFU approach does is that it has a separate, dedicated, smaller and optimized application for the firmware loading. So it uses the minimal Bluetooth LE SMP firmware loader. So the SMP is a simple management protocol, and that application is used to perform DFU over BLE. So that application, as I mentioned, provides minimal and recommended configuration. So we really make it small and contains only the functionality that is needed for firmware loading. So today this is experimental, and in terms of hardware, it is on the nRF54L15DK, but we are expecting to expand support towards other targets as well, and of course increase the maturity from experimental to supported on an upcoming release. Okay, so moving on to Bluetooth updates. Bluetooth LE and Bluetooth Mesh. So starting with Bluetooth LE, now we have support for Bluetooth Core version 6.2. This is also qualified. you can find the qualifications or the listings in the device-specific compatibility matrix. So depending which device you're using, if you go to the documentation for that device, you'll find the qualifications listed there. It brings this new version, the Bluetooth Core specification, brings a few new features. The main feature that we're highlighting in this release that we're also supporting in the SDK is SCI. So SCI stands for shorter connection intervals, and I don't think this could be any more descriptive what this means in practice. We'll show you. I'll talk a little bit more about SCI in the next few slides, and we also have a demo the next few minutes. If you want to learn more about this version and additional features that come into this version, we have a DevZone blog. And I'll leave a link here on the slide that you can follow, or just go to the DevZone blog and you'll find that. It's one of the most recent ones. Then on Bluetooth Mesh, we added a new sample, Bluetooth Mesh NLC HVAC integration. So HVAC is now supported as part of Bluetooth Mesh profiles. And we also updated multiple Bluetooth Mesh samples to support NLC. NLC stands for Network Lighting Control. So it's a sort of a higher level abstraction, specifically geared towards lighting and lighting controls. So what this means is that existing samples in the SDK for Bluetooth Mesh that implemented either lighting or lighting control functionality are now compatible with NLC. So that's the update, basically. There's also a few improvements for Bluetooth in the QoS channel survey feature. So this allows you to scan the different channels and try to understand if there's noisy channels, or specific channels can be more noisy than others. And then you can update the mapping to avoid those channels and sort of make sure that you're running the channel hopping using the channels that are noise free, let's say. There's been some improvements there. Also on the SoftDevice controller, the scheduler now has a little bit more flexibility on how you can manage events, both on the lower end, so you can schedule events that are less than 100 microseconds apart, and the time slots can now run longer than 128 seconds. And there's also some code size improvements on the SoftDevice controller for the 52 and the 53 series devices. This depends a bit on the configuration, so it's difficult to give you a figure. But if you're migrating from an existing SDK version to 3.2 and you're using nRF 52 or nRF 53 series, you should definitely see an improvement there on your application. Okay, so digging a little bit deeper into SCI. As mentioned, this is one of the key features in the Bluetooth Core specification 6.2, and we're quite happy that it's now been included in the Bluetooth spec, because Nordic was a major contributor to this specific specification for SCI. So what this brings is that it's quite suitable for applications that include low latency use cases. For example, gaming, whether it's casual to competitive gaming use cases, HID use cases. One thing that SCI also mandates is support for Bluetooth LE connection subrating. We covered this feature on the 2.8 and 2.9 SDK releases webinar that were done as part of the webinar, as part of the same webinar, and that also included a demo. So if you want to know more about this feature, I recommend that you watch that. But in a nutshell, what this feature enables is that it can switch quickly between low power or low latency, or in other words, between a short or longer connection interval without changing the connection parameters directly. So you can just basically skip connection intervals to go from low power to low latency very quickly and back. So if you think about the use case for gaming HID, let's say you have a mouse and you're playing a game, first-person shooter or something that requires quick reaction. You could be in a low latency mode, and then when you come out of the game and you're just doing regular web browsing, then you can go to a more low power mode where you don't communicate as often between the mouse and the computer. So how does this work in practice, this SCI feature? So if SCI is not supported, this means basically status quo prior to 6.2. So the connection interval goes from 7.5 to 4 seconds with a resolution of 1.25 milliseconds. So if you have a 6.2 device that does not support SCI, it means that the connection parameters or the limits and everything about the connection parameters is the same as it has always been. But now this has a name. It's the baseline con interval values, or BCV. Then if SCI is supported, the mandatory range goes down to 1.5 milliseconds, but the upper limit stays the same. So it's still 4 seconds, and the resolution is also the same. And this is the rounded con interval values, or RCV. So basically, you just go from 7.5 to a minimum of 1.25 with the same resolution. So you can do 125, you can do 2.5 in steps of 1.25 milliseconds. And then optionally, on top of the mandatory, you have the optional extension range when SCI is supported, which is the extended con interval values. And this brings the connection interval all the way to the microsecond realm. So 375 microseconds while keeping the upper limit at 4 seconds. It also brings down the resolution by a factor of 10, so an order of magnitude, down to 125 microseconds. So first we have BCV, so this is the default, standard connection interval values prior to 6.2. Then you have rounded con interval values, or RCV, that brings the lower limit from 7.5 to 1.25 while keeping the same resolution. And then you have the extended con interval values that bring both the minimum from 125 to 375, as well as the resolution tenfold. So basically from 1.25 milliseconds to 125 microseconds. Yeah. So when it comes to which devices support SCI, so it's supported across the entire Nordic portfolio from the 52 series, 53, 54L, and 54H. The minimum achievable connection interval as of now varies a little bit depending on the device. The 54L series is the most optimized so far, so you can go down to 750 microseconds, and you can find this information in the SoftDevice controller documentation. Okay, and now I'm going to show you a demo that my colleague Sebastian prepared to show that showcases the SCI sample running on 54L series development kits.
Time for a demo. We're going to demonstrate how the short connection interval works, how can it reduce the latency, and how it affects the power consumption. As both the central and peripheral device must support this feature, we're going to need 2 development kits. We will use the popular 54L15DK in this video, but it should also work with other devices that support Bluetooth 6.2. For the power measurements, we will use the Power Profiler Kit 2. First, we need to create a copy of the sample project. Once the new SDK is installed, we can use the nRF Connect extension to create it, following the usual steps. We need to search for short connection intervals. Then we must add the build configuration. There is no need to do 2 different builds for central and peripheral, as that's configured in runtime. So we only have to add 1 configuration and build it once. When the build is finished, we must flash the same firmware in the 2D case. In this setup, we must ensure that the power profiler is on and active first to be able to flash the DK connected to it. Then we can start the flash process. And finally, open the console of both devices. And reset both. The firmware first asks if it should initiate the connection interval updates. Only one should do it, and can be either the central or the peripheral device. In this case, we will start it from the peripheral, so we type the character Y on its console and N in the central DK. Next, the firmware asks for the role of the device. In this case, we follow the naming convention of the decays. We can see in the console that once the connection is established, every 3 seconds, the latency value changes following the interval requested. What about the power consumption? We can check the power profiler tool for that. Because the connection interval changes every 3 seconds, it is convenient to set the PPK period to 1 second. That helps to stabilize the average current measurement for better readings. We can see how the value settles at different points depending on the interval used. Naturally, the highest current consumption values match the shorter connection intervals. Please keep in mind this sample project has the UART and login enabled. That's the reason these averages are so high. We can also do another check. Let's stop the data capture and start a new one limited to 15 seconds. Because the sequence of connection intervals is 750 microseconds and 1, 1.25, 2, and 4 milliseconds, changing every 3 seconds, in this new capture we're guaranteed to have several different intervals captured at the same time. After it's complete, we can zoom into different parts and measure the time difference between current peaks that are caused by the radioactivity. We can see the intervals match the values we set and are well below the old minimal value of the spec. And that's it. That's the short connection interval demo. Let's move on to the next topic.
Okay, that was a great demo from Sebastian. Now we have updates on Wi-Fi. Just one slide in this section. So first, on the supported category, we now have Wi-Fi Alliance Enterprise certification. I leave a link to the certification here on the slide for WPA2 and WPA3 encryption on nRF 7002 DK. And then on the experimental, so if you're, we already discussed the nRF 54 LM20A SoC, which brings more NVM, more RAM, and that makes it an ideal host to the nRF 70 series. So now it's experimental status using the nRF 54 LM20 as a Wi-Fi host. And to enable that, we also brought out a new expansion board that plugs into the nRF 54 LM20 DK. So that's the one here on the right-hand side that was launched late last year into the market, and yeah, it's available. Also experimental is Wi-Fi direct operation on the nRF 7002 and nRF 7002 DK, and we added support for Wi-Fi direct to the Wi-Fi WFA Quick Track Control application. So it's available there now to be tested. Okay, now for updates on Matter. So I guess the biggest update is that we now have support for Matter 1.5.0 that was recently introduced by the CSA, or Connectivity Standards Alliance. They have a blog that goes into more details on this, and there's a link on this image over here, so you're free to go and check that out. Just trying to summarize the updates. So camera support is now a part of Matter. So this enables interoperability video devices with WebRTC streaming, multi-stream options, pan, tilt, zoom controls, and flexible storage. The other thing is that it now unifies closures model, which simplifies development. So closures are things like shades, drapes, awnings, gates, and garage doors. So essentially they all have similar operation. You open, you close it, or you open to a certain position, and you have some safety features there. Unifying this basically improves consistency, safety, and user control for that type of devices. It also brings some additions or some new functionality to energy and water management through soil sensors, some smart metering updates, tariff data sharing, and enhanced EV charging capabilities. And lastly, improved performance with full support for operations over TCP transport. And what this does is that it enables more reliable, large data transfer, which strengthens Matter's foundation for secure and interoperable smart homes. So that's Matter 1.5.0. And again, if you want to get to the details, I recommend going through to the CSA blog on the Matter 1.5 release. A few additional updates. So not surprisingly, as we mentioned that Wi-Fi is now experimental on the nRF54 LM20 SoC. Matter over Wi-Fi is also experimental on the nRF54 LM20 SoC, again combined with the newly launched nRF 7002 expansion board 2, which fits into the nRF54 LM20 DK. And because we are now introducing this, we're also deprecating Matter over Wi-Fi on the nRF5340 SoC. So this has been so far our recommended approach for Matter over Wi-Fi designs. But now the recommendation is that you switch and you adopt nRF54 LM20 for Matter over Wi-Fi design. So the main reason is that the nRF54 LM20 20A provides significantly more resources, so more larger amount of non-volatile memory, as well as and more available RAM for compared to the nRF53. Actually, I think they have the same amount of RAM, if I remember from the top of my head, but at least the part about larger non-volatile memory is a big plus, especially for Matter over Wi-Fi devices that require more space for the full stack to run before you even get to the application. And then we have a couple more updates before we go into the demo. So now on the scope of development tools, so there's 2 new tools available in nRF Connect for Desktop today. So if you have nRF Connect for Desktop and you update that, you will see 2 new tools. The first one is the Matter Quick Start. So this is quite similar to the Quick Start that you use for Bluetooth LE with the nRF54 L15 DK, for example. But this one is geared towards Matter. So what this enables is fast and easy evaluation of our Matter solution, meaning that you can flash. So it has precompiled firmware options, and you can flash the firmware without having to install the SDK and the development environment. And it also provides step-by-step instructions to set up your device and to add it to a Matter network. So you can actually do evaluation without having to go through the SDK and development environment setup. So that's the one here on the top left. And then the other one is the Matter Cluster Editor. So whereas the Quick Start is more for people who are just initiating with Matter, the cluster editors for more advanced users and developers. So this one is specifically for creating manufacturer-specific clusters. So this means you want to create a device that is not part of the standard, it's not part of the spec. So then you have to use a manufacturer-specific cluster, and this tool allows you to do that easily through a graphical interface. This has been available since nRF Connect SDK 3.0, but it was initially a self-contained application that you had installed separately. We called it the preview tool. Now this is part of nRF Connect for Desktop, where you can find most of our development tools for the various wireless technologies. Okay, and now we're going to show you a demo that our Matter team prepared for the Matter Quick Start. So you can see how that actually works in practice, from flashing a device all the way to adding it to a Matter network. Okay, let's move on to the demo then.
Hi everyone, my name is Kamil and I'm going to show you a quick demo of Matter Quick Start PC tool. This tool is available as a part of nRF Connect for Desktop, so after updating it to the newest version, you will find Matter Quick Start official 1.0.0 version there for you to be installed. I'm currently opening it, and the first view you can see is the list of Nordic DKs connected to the PC. For me, there are 2 of them, nRF54 L15 and LM20. The first one has some name assigned as I used before, so I can choose this time LM20. Yeah, the next view presents a brief description of hardware you selected, and it's a highlight of advanced documentation you can find under the link if you would be interested in it. Next, you can customize the DK name, but this is optional, so I'm going to skip it. And another thing to be done is selecting the firmware to be run onto the device, so you don't have to compile it. The hex file to test is there just for you. You can select among 4 examples. Let's say in my case, I want to evaluate matter light bulb, so I will choose this sample. And now it's programming. You can monitor the progress bar. And it's done. The last step is firmware verification to make sure it works well. And it succeeded. You can see the light bulb was booted in the device logs and the green mark that everything went just fine. Next, you need to select the commercial ecosystem that you want to test the device with. There are 4 of them available. Let's say I want to use the Apple Home. And then you can see the requirements, what is required to start. So the Home Hub device and the mobile app that you can get after scanning QR code. And every selected path includes the dedicated set of instructions. For example, if I choose the Google Home, it looks similar, just we have 2 QR codes instead of the one. And for the Amazon Alexa, it's the same thing. Yeah, so moving forward, as I mentioned, you need to have a specific hardware and software to start, and then you need to set it up. I have already done it. Yeah, but you can see that there is a precise step-by-step instruction what to do and what to click in the app. And what is even more convenient, for every stage there is a video that shows you how to do that. If you don't like to read the instructions, you can zoom it and watch it as many times as you need. And once your ecosystem is ready, you can start the device pairing. Again, there is a precise instruction with the video, but instead of reading it, I will maybe just switch to my camera and show you how it works on my desk. Yeah. So following the steps, I'm clicking plus and add accessory buttons, and I'm scanning the included QR codes. Yeah, I need to confirm the uncertified device. Now it's pairing, so it may take a few seconds. During this time, you will see that LED is blinking on the DK. And yeah, oops, once again, I need to select the location. Yeah, and you will see that LED 0 on the DK becomes solid on. Okay, let's move to the next view, which is interaction. Now I can change the brightness of the light with the slider. Yeah, observe LED 1 on the DK. Now it's completely off. So I can turn it on again. And turned off again. Yeah, so that's it. Let's get back to the app. You can see I managed to run it like in 4 minutes or so. Next, after the first run, you may want to learn more about the matter. So there is a list of resources prepared for you. You can request getting matter spec, see the repository, or read our documentation in nRF Connect SDK for this protocol. And also, if you would like to start development, there are several useful tools you can download. For example, you may want to get the development matter controller for the PC, that is chip tool. Yeah, or you may want to check online power profiler for matter. That is, yeah, allows you to estimate your device power consumption even without having hardware on desk. Yeah, next you can move to the development environment. So it's either VS Code or console. And you can also install other apps from nRF Connect for desktop. For example, you can see I have 2 of them installed as I find it useful for the matter development. Yeah, that's it. Thank you. And I encourage you to give us a feedback after you try Matter Quick Start tool.
All right, moving on to Cellular IoT Updates. So we have launched a new kit for the nRF 9151. It's the nRF 9151 SMA DK. As you can see here on the right-hand side, the form factor is about the same as the existing nRF 9151 DK, but instead of an onboard antenna, you have these SMA connectors. So the main purpose of this kit is that we're sort of on our way to start enabling NTN. NTN stands for non-terrestrial networks. If this is an unfamiliar term, it means exactly what do you think it means. So it means that the nRF 9151 will talk directly to satellites in orbit. So this, of course, expands the possibilities for cellular IoT deployments because you're not limited to terrestrial-based cellular coverage, which covers only a fraction of the planet. Obviously, over our extensive ocean surface, there is no cellular terrestrial coverage, and then you can have satellite connection as a backup to have truly global deployments that can connect from anywhere. So this new kit is a bit of a more specialized development kit, and it's targeting users who need maximum RF performance, flexibility. What you can do with it is that you can connect directly with lab equipment for testing and evaluation. You can also connect to external high-performance antennas, and it supports essentially all of the existing protocols that you had with the nRF 9151 DK. So LTM, NB-IoT, GNSS, NR+, and with the addition of LEO, NGO, NTN connectivity, which is experimental maturity. So this kit comes with antennas, and it also comes with SIM cards for connectivity, including for NTN connectivity. You can check more information on the webpage for this kit. So that's on sort of the hardware side. So there's support now in nRF Connect SDK 3.2.0 for the nRF 9151 SMA DK. Related to that, a few updates on the software. So there's a new library for NTN-related helpers. Of course, as I mentioned, we're sort of starting to bring up NTN support, and that comes with a few changes. Also merged the PDN library with the LTE link control library, and this is for compatibility with the new NTN-enabled modem firmware, which is separate from the non-NTN-enabled modem firmware. That's the one that's been there, so it continues to be supported. And then another update is that the serial LTE modem application, that's not part of the SDK anymore. It has been removed, and that is now replaced by the serial modem, which is now distributed as a nRF Connect SDK add-on. So you can take that separately instead of having it part of the SDK. And the add-on is something we covered on the previous webinar. So these are essentially software deliverables outside of the SDK that are compatible with specific nRF Connect SDK versions. So not all of them, so they only get updated or less often than as if they were part of the SDK itself. All right. Yeah, and the last topic is the nRF Connect SDK Bare Metal option. All right, so we've released a new version 1.0 of the nRF Connect SDK Bare Metal option. So what this means generally is that the maturity of the Bare Metal as part of the nRF Connect SDK is now supported, as has been experimental until now. And it's this makes it suitable for product development. So if you're not familiar with the nRF Connect SDK Bare Metal option, I recommend that you watch our webinar from around August-September timeframe last year, where we covered this. So so this is targeting the nRF54 L15, L10, and L05 wireless SoCs. So whether you're doing custom hardware or if you're just using the DK, these are all targets that are supported. So we have now two soft devices. So the S115 that's been there from the start was experimental, which is now supported. So this is a memory optimized peripheral only soft device. And we also introduced the S145. This is something that we disclosed at launch, that there was going to be a multi-role soft device coming as well. So this is now in the SDK. So this is multi-role, central, and peripheral soft device. And it's there as supported. So it's not experimental, it's actually supported. And the qualification for these soft devices will also be available quite shortly in the device compatibility matrix, as I mentioned earlier, for during the Bluetooth section. There's also some new samples and libraries like scanning, radio notification, database discovery, bond management, central for heart rate service. There's more, so I recommend that you look at the changelog for details. One thing that I'd like to highlight is that we've adopted the same nRFX version that's part of the nRF Connect SDK. So one of the common assets between Zephyr-based development and bare metal development is the nRFX layer. So that has been bumped from version 3 to version 4. And of course, this is a bit more impactful for bare metal development, because if you're doing Zephyr-based development and you're using the Zephyr APIs, this will be a transparent update, so you won't see any difference. But if you're coding your own drivers on top of nRFX, then you will see the change. But we have a migration guide that I'm also linking from this slide. You can easily find it in the nRFX documentation that will go through the major changes and the things you need to do in your code that you build on top of the nRFX to migrate from 3.0 to 4.0. Then a couple of experimental updates as well. So we added NFC as experimental, type 4 tag and type 2 tag. So this includes both libraries as well as a few samples. And just one thing to highlight here is that, so the S145 SoftDevice, it has supported maturity, but its integration as part of the wider SDK, so when it comes to using central functionality as part of samples and libraries with the S145, that is still experimental. So if you want to develop a device that has central functionality, you can use the S145 that is supported. But if you're taking a sample or a library as a starting point, then just want to make sure that that the maturity is experimental. But we're expecting this to be brought up to supported maturity quite soon in the future. Okay, and we're going to move on to the last demo of today's webinar. Again, something that's my colleague Sebastian prepared, which shows the S145 in action with some of the samples in the SDK. All right, so let's move on to the demo.
Time for the demo. We're going to demonstrate the new central capabilities of the S145 SoftDevice and its multi-role feature. This means it can act as a central device and also as a peripheral, talking with two separate Bluetooth devices at the same time. The list of required hardware is simple, and any viewer who is familiar with the Nordic development ecosystem should have most of the items. It's also assumed the viewer has some previous knowledge of how to work with the Visual Studio Code and nRF Connect plugin for development applications. To demo the new central capabilities of the Bare Metal SDK, we also need a peripheral to connect to. So we must use two sample firmwares running in two separate development kits at the same time. The SDK provides a set of sample projects for this, using the heart rate service, or HRS. To get the source code of the project, we need to create a new application, copy the sample, and select the bare metal option. It's usually a good idea just to filter and ensure only bare metal is enabled to avoid getting any sample of Zephyr by mistake. And once here, we search by the acronym, so we can see we have both the central and the peripheral device. We need to add both projects to the workspace. The build configuration of each project must use a different SoftDevice target. The peripheral will use the old 115 version, while the central will use the new 145. So we select the 115 for the peripheral, we select the project config, and trigger the build, which will take a few minutes. Once it's finished, we'll flash in the corresponding kit, which in this case is the peripheral one. We can confirm it's working correctly by checking the corresponding serial console and resetting the device. We can also confirm it's working with the nRF Connect app. Then we can repeat the step for the central project. In this case, in the build configuration, we need to select the 145 SoftDevice. And again, we build, which will take some time. When the build is finished, we need to flash it in the central device. And then we can also check in the console when it starts. Here we can see it's connected, and this was reported here, and we are seeing the same measurements in both devices, which means the central device is talking with the peripheral device. We can also demonstrate another feature added in this release, which is the multi-role. In this case, we can see in the console that the central and the peripheral devices are still connected and talking to each other, and at the same time, I can connect with the nRF Connect app to the central device and retrieve, for example, the device information. It's important to highlight that this code is not present in the sample code and has to be added manually, but it's not very hard to add the device information service and the advertising code. And the same for the code that handles the LED that indicates connections in the right, which helps to visually see the connection and disconnection. And that's it. Hope you like it, and let's move on.
Okay, and with that demo, we've reached the end of today's webinar. As usual, the key touch points for additional Nordic information. Of course, our webinars are at webinars.nordicsemi.com, both for upcoming ones as well as the on-demand. Really highly recommend that you visit the Nordic Dev Academy if you haven't done so yet. It's the best place to get started and learn about the nRF Connect SDK, as well as the various wireless technologies that we offer with interactive online courses, including hands-on and exercises. For tech support, place to go is DevZone. And for more broad information about Nordic's products and services, please visit our corporate website at nordicsemi.com. And with that, we move on to the Q&A. So let's now go through some of the questions that came in and try to provide you with some answers. Okay, so let's see. So quite a few questions came in. Some of them touch on roadmap, and that's not something that we will comment as part of the webinar. So things like more RAM on 54L15, or whether we'll have a successor to the 54840 dongle. Let me see here, which was the first one that I can tackle. There's a question about Matter over Thread on 5340. So that is supported today. I can put a link on the chat. Let me see here, to the software maturity table that shows that. Okay, so that link will take you to the table where you can see the maturity for Matter on the different hardware devices. Okay, and then also if we're planning, again, roadmap, but I'll call this one out, Matter over Wi-Fi with the 54L15. That is not supported today. It's mostly about NVM, so that's why the LM20A is a suitable device for this, because it expands on the NVM availability compared to the L15. Okay, what else? BLE sniffer for 54L15 evaluation boards. So today it's only on the 52 or handful of 52 DKs. And again, roadmap, not something we can comment on. BLE SCI supported on Bare Metal SoftDevice S15. No, this is not supported, and it's not planned to be. So essentially, the soft devices that you get with Bare Metal, they are qualified against the core spec 6.2. But when it comes to the features that are actually available, they will be equivalent to the soft devices that we had on the nRF 5 SDK. So there are more or less Bluetooth 5.0 features that you'll find there. But I'll also drop a link to the chat for the S115 specification, and there you can see which features are supported in more detail. Let me link here, and it's now on the chat. Can you add Google and Amazon for Matter Quick Start Guide? So there. I think there's 4 ecosystems, and depending on the ecosystem that you select, you will get custom guidance. So the guidance is not the same for all ecosystems. The one that we showed was for Apple. We just had to pick one, so it went with that. But you'll also find Google, Amazon, and I believe it's Samsung SmartThings that's also there. if I can remember from the top of my head. So essentially, yeah, you select the ecosystem, and then the videos that you see in the Quick Start application will be specific for the ecosystem that you have selected there. There's a question that came just now. In the samples shown, project configuration also selected as base configuration file. This is always done by default. I think it was. Maybe this was a change in VS Code. So I haven't looked into this. But if the behavior has changed, you can maybe ask on DevZone, and the tech support team can support you with that. Okay, if you have any questions, I can wait a few seconds for them to go. I see there's something in the chat. Most of them are moved to the questions. Yeah, we did not demo the cluster, the builder or the custom editor for Matter, and maybe we'll do it on a future webinar. I can take this one on the chat as well about Skylo support for NTN. So yes, we are certified with the Skylo network. I'm not sure if that is part of the 9151 SMA DK as part of the SIM cards that come with that. But I know that we are certified. In fact, I can even share perhaps the press release we had about that, and there's some additional information there. So yes. Okay, there's one more question. There's some evolution for DFU. I'm not sure what this means. I mean, we do now have, so on Bare Metal, we have only single slot DFU. So the same that we had on the nRF 5 SDK. On Zephyr side, on Zephyr-based development, we have both dual slot as well as single slot. Some applications you need to have, I mean, dual slot DFU is really the only option. Things like Matter, you need to be in the network while you transfer. If you're transferring the image from the cloud, for example, it goes through a gateway and then makes its way to your device. So you need to be part of the Matter network for the whole duration of the image transfer. And for that, the only solution is dual bank DFU. But if you're doing DFU from a phone into a device, then single bank DFU over BLE transport or Bluetooth LE transport is also now a solution available for Zephyr-based application development. Plan for dual bank DFU support in Bare Metal. We're not planning to add this. So again, this is to be almost as close as possible to the nRF 5 SDK functionality. But the solution there is based on MCU boot. So it is possible to add that dual bank DFU on Bare Metal if you wish to do so, but that's not something that we'll officially support. Okay, that might have been the last question. So I think we now reached the end of the webinar. Thanks everyone who attended, and I wish you the rest of a great day ahead of you. All right, thank you. Okay, so there's a few questions that I'll go through. Let's see. Okay, the first one, what is the difference between DFU on nRF 5 SDK and the SMP, so this solution for single slot DFU on Zephyr-based applications? Actually, I'm not fully aware of the details, so I recommend that you ask this on DevZone. Our tech support will be able to clarify that. Does the updated nRF Connect SDK come with any sample or application for the nRF 9151 SMA kit? Yeah, there's a specific set of applications. If you go to the product page, let me share the link in the chat. On the downloads tab, there's a set of applications you can use there. I think they might be precompiled actually, so you can just flash them. And of course, you have the applications in the SDK that can be used. I'm not sure which of them are using NTN. Again, this is something that I recommend that you ask on tech support. There's something wrong with the link, apparently. Let me see. Try that again on the chat. Okay, no. There's something is being appended to the when I put the link in the chat. But if you copy from HTTPS, then it should take you to the right place there. Okay. Yes. Can you please give more details on the improved QoS channel map? Yes, actually. So in the documentation, what happened is that the minimum interval that is required for running the channel mapping was reduced from 7.5 milliseconds to 3 milliseconds. So what this means is that channel survey, you can run it in chunks, so in incrementally. So even if you don't have 7.5 milliseconds of radio time, you can still run it, and you get the result for a subset of channels, and then you run it again, and you get the result for another subset of channels. So you can sort of interleave that in smaller slots instead of having to wait for a longer slot to be available. And then with that information, you can do what you have done before, which is updating the channel map and trying to avoid some noisy channels on your environment. Another one, this is actually an interesting one. How does SCI affect Bluetooth Mesh? Actually, it doesn't, because Bluetooth Mesh runs on advertisements. So that's on the network side of things, if you will. But it could be that could bring improvements potentially, maybe for proxy nodes when you connect to the mobile phone. But that, of course, requires the mobile phones to support SCI, and that's something that we don't have visibility on. Can you use the nRF 7000, I suppose it's 7002 DK with Matter Quick Start tool? Good question. I believe for now it's only the Matter over Thread that is supported there, but I'm not 100% sure. Maybe in DevZone, or if you have one, you can try it and see if it works. But if not, then maybe in DevZone they can clarify. Does Matter over Wi-Fi on 54LM20 support ICD? So Matter over Wi-Fi and over Thread, or Matter in general, on LM20A is experimental. ICD is supported. I'm not sure if ICD is exclusive to Matter over Thread. It could be that it runs on Matter over Wi-Fi, but I don't see how that will bring a lot of benefits, because the Wi-Fi devices, they will be waking up to the DTMs anyway, unless you have, of course, target wait time. In that case, you can sleep for longer periods of time. But ICD, I believe, is more geared towards Matter over Thread devices, which are typically battery powered. But if you're using TWT, which I don't think it's widely supported yet on access points, it could bring some benefits there as well. But I think it's more for a Matter over Thread device. And then what does the PDN library stand for? So that's Packet Data Network. So that's a modem library to abstract some of the AT commands that are used to manage data packets towards the modem side. Do you have any idea if SCI will ever be available through Bare Metal? No, we have no plans to add this to the SoftDevice on Bare Metal. So the Bare Metal SoftDevices, both the S115 and the S145, they are qualified against the core spec 6.2. But when it comes to features, they are equivalent to the SoftDevices that we have on the nRF 5 SDK. So that means mostly Bluetooth 5.0 features. The qualification is against 6.2 is more to give it sort of a longer runway that customers can adopt these SoftDevices and qualify their end products, and they will be able to be in the market for a longer time. There is no mention of support for the 54H20 in the webinar. So the 54H20 is still only available to select customers, and when it comes to maturity, is experimental. So that's something that we, for as long as it's in that state, probably it's not something that we're going to cover as part of the webinars, at least not in these webinars, of course. Can the nRF 9151 be used to add a speaker and microphone in an effort to port over PJ-SIP and try VoIP call? I actually don't know. I'm not so much into cellular IoT. So again, this is something you could probably ask on DevZone. We'll be providing a Matter camera example soon. I don't know, roadmap, so hard to comment on this. Maybe with Matter over Wi-Fi could be a possibility, but I would just say that you need to stay tuned for upcoming webinars. And if it's there, then I'm sure we're going to cover it, and hopefully also have a demo. Okay, I think that's it. Oh, I see there's a question on the chat. I can maybe take this one. I have only used Zephyr. Is there a real advantage to the Bare Metal option? Well, if you're developing on nRF Connect SDK, then there was really nothing for you on Bare Metal. The one thing that could have been was the single slot DFU, but now that's being introduced to Zephyr-based development as well in the nRF Connect SDK. So our recommendation is that you stay there, because all the new developments will come
to nRF Connect SDK, I mean to the Zephyr side of things, not on the Bare Metal. So the Bare Metal is mostly there to bring customers from the nRF5 SDK who are not, let's say, ready to fully embrace Zephyr-based development. They can start with Bare Metal because they're both built as part of the same SDK, and they both sit on top of the same tool chain and the same development environment. So it gives you sort of a familiar starting point, and then as you develop Bare Metal applications, you can also start experimenting with Zephyr-based applications, and that's really the long-term solution. Continues to be on the Zephyr, and we're fully committed to that. Okay, a couple more questions that came in. Do you have any some information about Newton on nRF 54? We had an announcement at CES just last week, so I just recommend that you go and check out our Edge AI page. Everything that is public is on that page, and of course there was also a press release that talked about Newton. But as part of this SDK release, there was really nothing to highlight when it comes to Newton models on nRF 54. Okay, back to the Matter over Wi-Fi. We want to use it on a battery-powered door lock. Does Matter over Wi-Fi support deep sleep between beacons? Yeah, with the target wait time, you can have deep sleep, and you can extend the period between beacons. So you don't have to wake up to every DTIM. You can extend that so you can sleep for seconds up to minutes, but then you need your access point to support that as well. So it's a Wi-Fi 6 feature that needs to be there. So it is possible, but I think it depends on the access point. Yeah, okay, I think that's it for today. Thanks everyone who attended, and wish you the rest of a great day ahead of you. Thank you.